Hello friends, welcome to my channel. Let's have a look at problem 2398 again, maximum number of robots within budget. So in a previous video, we actually shared a solution format based on two-pointer sliding window technique, but with the help of a sorted container, a sorted list in that video. So in this video, we're going to present another solution format. So still using two-pointer sliding window technique, but with the help of monotonic stack. So here the role of the monotonic stack is to help retrieve the maximum charge time in a window. So the idea when we talk about the two-pointer sliding window is the same as the previous video. So for each right pointer, let's call it right here. So we want to find the left pointer left such that the condition specified by the problem holds. So this way, we can update the maximum number of consecutive robots by result equals the previous state of the result, and then the right minus left plus 1. So this is the length of the subarray. So before we write the code, I want to emphasize one thing again. So that is the monotonicity. So it's the monotonicity that makes the procedure of sliding window work in this problem. So to be more specific, so for two right pointers, let's say R1 and R2. So if R2 is larger than R1, let me use strictly larger. So in other words, so R2 is in the right of R1. Then there must hold L2 is greater than or equal to L1. So this is the property that makes the sliding window method or procedure sound and effective. So with that said, I guess we should directly look at the code now for this format. So we're going to split the code into two parts. One is preparation and the other is the sliding window. And logic check. So parallel to the previous solution format. So for this, I'm going to initialize a stack. So this stack is used to retrieve the maximum value in charge time via recording indices. So we're going to also initialize left and right. So these are the two pointers. So we're going to iterate. So also we are going to initialize a result variable whose final state is what we want to return. In other words, result records the running maximal subarray length or maximum number of consecutive robots which satisfies the condition in the problem statement. So for convenience, I'm going to get the length of the two arrays, charge times and running costs. The length, I'll call it m. And then I'm going to initialize another two variables called running cost initially to be 0. So we want to record the total cost in the window. So and also the total cost will be 0. So the total cost is used to check the conditions specified in the problem. So these are the preparations. So when we look at the second part, so some of the variables meanings will be more transparent or obvious. So for this, I'm going to do a while loop. So we can do a for loop, in fact. So while right is less than m. So for the right index, we're trying to find the left index. So we want to push the left as possible actually. So to maximize the length at the problem requirements. So first, so we're going to use a monotonic stack to retrieve the largest charge time in the valid window. So for this, so we're going to use this condition, while stack. If stack is not empty, then we can do the check. So we can charge time. So we want to check the top index in the stack. So we want to check this charge time. If it's less than the charge time for the current current in the red pointer. So if this is the case, so we're going to do pop, stack pop. So in other words, we want to retain a monotonic decreasing stack. So this way, the stack 0 or stack left, more precisely I will say stack 0, will correspond to the largest charge time in the window. So this is the while loop. So this is the standard monotonic stack check condition, right? While stack is not empty, then we can further check this condition, right? So notice that in the stack, we are storing the indices, not the specific charge time. So after we exit this while loop, there are two possibilities. So either the stack is empty or this condition holds. In other words, the charge time at the stack top is no less than the charge times at the current red pointer. So either way, so we want to add the current index. So that is right. So this way we finished a large step. So next, so we're going to add the current cost to the running cost. So that is running costs rate. So we are ready to next. We are ready to compute the total cost in the current left to right, and then we check the condition and move the left to the right if necessary. So let's see, the current total cost is the following: is the charge times stack 0. So as we mentioned, so stack 0 corresponds to the largest charge time. So this corresponding to the max charge time in the definition of the total cost. Then plus the length, so that is right minus left plus 1. Then multiply by the current running cost, right? So this is the total cost for now. Let's do it like this. Next, we are going to do the check. So we are going to check the condition. So sliding window logic. So for this, what we are going to do is that, well, total cost is greater than budget. So we need to remove some robots from the very beginning. In other words, this corresponds to push left to right. So then we're going to do the check if stack, so and charge times. So we want to check if we move the left, so if we move the current largest charge time. So if the left equals charge time stack 0. So if this is the case, so we're going to pop the 0 element from the stack. So in this way, we actually update the maximal in the window. So after we do this condition check, so what we are going to do is that, so we are going to running cost, so minus the running costs left. So then this actually corresponds to move the left to right by 1. So after we do this, so we are going to update the total cost, right? So there are two possibilities. So if stack, so or not. So we can write actually as one line, but let's first write into the if-else block form so that we can fix the idea. So if the stack is not empty, in other words, the window is still not empty, so the total cost will be the largest charge time, which will be the charge times, so stack 0. Then plus the right minus the current left plus 1 times the running cost. So that's the update. Otherwise, if the stack is not is empty, then actually we have an empty window. So in this case, we're going to reset the total cost to be 0. So this is the writing format. So if we want to save some line of code, so we can actually update it like this: total cost equals this if stack else, so 0. So we can delete this block. So that's the update. So after we do the update, so actually we are ready to update the result as in the previous video. So we need to exit this while loop. After this while loop, so we're going to have a valid condition, that is total cost less than or equal to budget. So in this case, so we're going to update the result to be maximal of the previous result state and the current length, that is right minus left plus 1. So once we done this, so we should exit this while loop. So after this while loop, so for each right pointer or index, we find the corresponding left pointer, and then we update the result. So then we just need to return the final state of the result variable. So that's the logic of this sliding window method if we use monotonic stack. So here the role played by the monotonic stack is still the same as the role played by the sorted container in the previous video. So with that said, I guess let's first do a special case check. So I guess I forgot one thing, that is, so we need to increment this rate. So let's do this. Right plus 1. So because here we are using a while loop, so if we use a for loop, so we don't need this update. So let's do a check again. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this format of solution to the problem. So let's give a quick summary. So in this solution, so we used the standard two-pointer sliding window technique. So in order to track a maximum for a charge time, so we used monotonic stack in this format. So because of the way we used the stack, so the stack 0 corresponding to the largest charge time index. So this way we can easily compute the total cost and do the logic check. And in between, so we can update the result. So here one caution is do not forget to update this right pointer by 1. So after we exit this inner while loop. So I guess with that said, so that's about it for this solution. So if you like, you can try to write this format using a for loop. So yeah, that's about it for this video. Thank you very much.